Hello everyone, this is Unit 4. Alright, we're starting a whole new unit. We're going to be talking about transformations, rigid motions, and congruence. Okay, so today we're going to be talking about some of the most basic transformations, okay, the ones we're going to be seeing in this unit. Okay, perhaps maybe you've seen some of these before in earlier years, okay, but if you haven't, well, I don't think today's lesson is going to be too much above you, okay? We're just kind of talking about these different transformations, okay? Tomorrow, or the next day, we will start actually performing some of these specific transformations, but we're just going to analyze the 4 different types we're going to see, okay? So, exercise 1, since we got the picture of a dog in A below, has been transformed into the image in B. Describe all of the different transformations that have occurred to A in order to produce image B. You don't need to use a technical terminology yet, but may do so if you remember. So maybe pause the video and take a second to think about what this dog, okay, what happened to it, right? Well, first thing we could notice is that it's been kind of rotated, right? Rotated to the right, okay? So there's a bit of a rotation, if you will, okay? Also, it looks like it got smaller, right? It looks like the picture of the dog got smaller. And then finally, okay, this last one might not be so obvious, but the dog's not in the same position, right? It actually got moved. It got moved or shifted to the right. Okay, so it was rotated a bit, it was shrunk, and then it was shifted or moved to the right. Okay, and so that's how we got that image of B. Okay, so you'll hear that term thrown out there a lot throughout this particular unit, this image. Okay, so what that means is after a transformation, okay, you are left with a different image, right, or a different representation of that first object or that first in this case, picture of a dog, okay? So just keep that in mind when I say the word image in B, okay, what I'm talking about is after the transformation, what happened to our shape, okay? What happened to our, our point or whatever we are dealing with, okay? And so that's what that means when I talk about image, okay? So it's below the image of the rabbit face A, okay, has been transformed each time to image B. Match the transformation with its proper name. Okay, so maybe take a second and pause and think about which one of these you might perhaps remember. Okay? And that being said, if you didn't pause it, well, I'm just going to keep talking. Okay? And so, a reflection, okay, is like looking in the mirror, right? When you look in the mirror, hopefully, right, you see the same image. If you don't, it sounds pretty scary, right? So, a reflection is going to be this guy right here, right? It's the same image, but then kind of flip-flopped over that line separating those two, right? So it's been kind of reflected over that dotted line, okay? So that's a reflection. You get a different color here. A dilation, okay, is where it's made, right? It's where our transformation is either grew, all right, our image has either gotten bigger or it's gotten smaller, okay? So which one of these 4 looks like a dilation? It's got to be this guy right here, right? Looks like our image of our rabbit got a little bigger, okay? So that's what it means to be a dilation, right? The size of our image either gets larger or smaller, okay? Next is translation. So let me get a different color here. So translation is where, like I said up top there, where our image just moves, right? We don't rotate it. We're not reflecting it over any particular line. It's not getting larger or smaller. It's just getting shifted to the left, to the right, up or down, okay, wherever our translation is telling us to shift it. So that's this guy right here, right? Our image of our bunny rabbit, okay, hasn't changed, okay? It just got moved up to the left, up and to the left, okay? And then finally, our last one, it's got to be rotation, okay, which means, okay, you take an image and it's rotated to some degree about some point or around the, in this case we're going to be talking about rotating it 90 degrees, 100 degrees, so basically using our axes in order to rotate these images, okay? So rotation just means it is being moved, all right? So it's very similar to a translation, but it's being kind of shifted in the sense that it's moving so many degrees, right? So if it's moving 90 degrees, you know, this one looks like 40, but if we were moving 90, right, your image would be somewhere over there, right? So it was shifted 90 degrees to the left, okay? So it shifted 180, then we'd have the image looking down here, right? Shifted 270, right, be over here. And if we shifted this image, if we rotated this image 360, well, guess what? We'd be right back to where we're at, okay? So that's what it means to be a rotation. So here's kind of a boring definition, okay? Always got to include these, but a transformation, f, is a function or rule that for every point P in the plane as its input gives or assigns another single point in the plane f of P as its output. Okay, so basically what that is saying, right? It's a fancy terminology, but transformation is where you take a point, okay, and then assign it, you know, either one of these four transformations, either, you know, the image gets bigger, smaller, we're rotating it, reflection, okay, and then the output is whatever that new image is. So your input is kind of like your transformation, and then your output is your new image, if you will, okay? All right, so transformation rules apply whether we are doing geometry in Euclidean plane, no coordinates, or in a Cartesian plane with coordinates, okay? So we're going to spend a lot of time here. Okay? This is where we're hanging out, okay? We're going to be doing a lot of these transformations in the coordinate plane, okay? So up there, we didn't have any points, so that was kind of like a Euclidean plane transformation, right? That dog was just moving, or the bunny rabbit, okay? We are going to talk about transformations happening more or less inside the coordinate plane, okay? So anyway, triangle ABC is graphed below with the vertices -4, 5, -6, -4, and 4, -4. Use the following two rules to produce triangles ABC and or ABC prime, and then A double prime, B double prime, C double prime, okay? So those little dashes just mean that it's a completely different image than our first AB, okay? So let's talk about how we find this, okay? So here's our points. -4, 5, okay, this is A. B is -6, -4. And C is 4, -4. Okay? And so we're going to take these points, all right, and we're going to plug it into this, well, this rule here, right, this function. Okay? And so it looks like what we're doing is we're taking that x value and we're adding 2 to it. Okay? So -4 plus 2 will give me a -2. And then it looks like we're taking that y value and just making it negative. So here is -2, -5. Add 2 here, so it's -4, +4. And then this one's going to be 6, 4. Okay, so that is our transformation. Okay, we took these points, right, and we adjusted it based off of what our transformation is. Okay, and so let's mark those new points in there. Zoom in here a bit. Get a nice red color here. So -2, 1, 2, 3, 4, 5. All right, -4. +4. Okay, so this is A down here, prime. This is B prime. And then C prime is going to be 6, 2, 3, 4, 5, 6, 4. 1, 2, 3, and 4. So there's C prime. And so let's connect those guys. Okay, and there is our new triangle, okay, based off of that transformation. Okay, and this is what we call a well, I wouldn't want to call it a translation, okay, because we definitely, well, as you can see, those A and B and C values got kind of flipped over that x-axis. So I would say this is a translation and a reflection. Okay, and we'll get better at distinguishing these, but as you can see, right, our A, B, and C value got shifted, and then they also got shifted what? Got shifted to the right, right? Everybody got shifted over 2 spots, and then it got flipped over the x-axis. Okay, so anyway, let's take a look at number B. Letter B. Okay, so this one, we got to make sure we got those same points. Okay, so let me zoom out for a second. So A is -4, 5. B, -6, -4. And then C, 4, -4. Okay? So, anyway, now we're going to do the same thing we did on the last one, right? We're going to apply those rules. Okay, so I'm going to go -4 divided by 2, comma, 5 plus 5. -6 divided by 2, -4 plus 5. 4 divided by 2, and again, -4 plus 5. And so when we shrink this down here, all right, and so we get an answer, -2, comma 10, -3, comma 1, and 2, comma 1. Okay, so let's draw those in there. So -2, comma 10, it's going to be up there. -3, comma 1, and then 2, comma 1. So this is A prime, or double prime. This is B, double prime, and then this is C, double prime. There is our new triangle. Okay, so it appears that we moved up 5 spaces, right? So there was a translation, right? We moved up 5 spaces, but then it's also a dilation in the sense that we shrunk, all right, our x values, right? As you can see, our triangle appears to be a lot smaller than it did before. Okay? And so, the question below asks, based off your observations, which one of these 2 transformations maintained the size of the original shape? And I would say the first transformation. Okay? And transformations that preserve shape and size are what we call rigid motions. Okay? And so, I guess I forgot to do this. All right, so let's talk about, all right, the definition of a rigid motion. Okay? What does that mean? So, Google search here. Let's see what that means. So, definition of rigid. Okay, this is coming right from Google Dictionary. Okay, so rigid is an adjective. All right. And what it means is that it's unable to bend or be forced out of shape. Okay, so that's what a rigid motion means. So if you put it in context of what it means as far as these transformations, what it is saying is that it does not change the shape or size, right? It preserves that particular shape. In this case, we were preserving the shape of a triangle, okay? But just in that first transformation. In the next one, we shrunk the size of our x values by dividing it by 2, Okay, so we're multiplying it by a half, so we cut our x values in half, and that ultimately made our triangle smaller. Okay, so last problem here. So using transformation rule F, given below, create the image of triangle ABC on the same grid, label it A prime, B prime, C prime. Okay, so here's our rule. All right, now they didn't give us the points, and so let's do that. So A is, looks like 2, 3. Okay, B looks like it's 9, 1. And C looks like it's 9, 6. Okay, and so what the rule is we're taking those points and we're switching them. So it's going to be 3, 2, 1, 9, 6, 9. Okay, and then we're also negating that y value. So here's our new triangle. Okay, so let's mark this in here. So A is -3, 2. B is -1, 9. And then C is -6, 9. Right? Whoops. That's 10. Hello. -1, 9, and then -6, 9. Okay? So there's our new triangle. All right. Now, the question is asking, what transformation rule does this represent? What does it look like we did? Okay. Now a reflection, if we reflected it over this line right here, right, we would get basically the same image just facing the other direction, right? We would get something looking like this, okay? So we didn't reflect it, okay? We didn't move it, right? We didn't just shift it, okay? And the triangle doesn't appear to be smaller, and so this is what we would call a rotation. Okay, in fact, we rotated it, okay, looks like it rotated 90 degrees, right? Okay, and we will talk about how we come up with that, but this is a rotation, all right? So did it preserve size and shape? Sure did. Okay, as you can see, if we wanted to find this, or if we wanted to prove that, we would have to use the distance formula, but just take my word on it that we did preserve the size and shape. Okay, so therefore the three transformations which preserve size and shape are called rotations, reflections, and then finally translations, where we just shift it. Okay, it doesn't get rotated. All right, translation looks more like this. Okay, or moves over here, or maybe it goes back down this direction. Okay, it's not, as you can see, we're just pointing, all right, that we're just always pointing north here, right? So it doesn't, translations don't shift it in a manner that we go from here and then now we're upside down. Okay, that's not a translation. That could be part of a translation, but also there's a rotation involved there. Okay, so this is a rotation up here, all right, and in fact it's rotated 90 degrees about the origin. Okay, and we will discuss how, I will show you how to do that, but as of right now we are just trying to distinguish what kind of transformation we are looking at. Okay, so anyway, don't worry about that 90 degree about the origin. Just know that that's a rotation in the sense that we shifted it or rotated it 90 degrees. Okay, so the transformation which does not preserve size and shape is the last one, which we already discussed earlier, is called a dilation. Right? So that dilation either can encourage the image to get bigger, or not encourage, but forces the image to get bigger, or it gets smaller. Okay, so hopefully this lesson didn't take too long. Okay, I want you guys to watch this, and then tomorrow we will work through the homework problems in class. Okay, so good luck, you guys.